expand on what I did on the last Mountain West Ruby conference. So let's see if this works. Okay, there we go. So what is this crystal language? Let me tell you a little bit of how the language got started. There's a yeah, that's it. Okay.
If your screen's going to come up here when you do it, then yes.
Yeah. I'm going to swap between this and that. So, like I was trying to tell you, first, this language got started because a company back in my hometown, Buenos Aires, Argentina, actually got started doing Ruby on Rails and Ruby development for a very long time. And they reached many times the point that they needed things to go faster. And also because they came from other languages, they also love things like type checking. So that's how it originally got started. So it is definitely not Ruby, but you will see that it feels a whole lot like Ruby. The language is heavily inspired in Ruby in the syntax, in the way that it works, and I guess one easy way to say what is Crystal is basically Ruby running really, really fast. But there's more to that. Let's take a look at how somebody was asked to define Crystal in just a tweet, so 140 characters. And this is what he said. Has friendly syntax, has static type checking, has a modern standard library, compiles into efficient, easy to distribute native code, has macros, and is self-hosted. So we're going to try to go through all this, what all these things mean, and see if we can expand a little bit, just give you a taste of what it is, and maybe that will pique your interest. So let's take a look at a good old adage of computing. Once you get past hello world, you start looking into Fibonacci and what it means. And this is a definition. Now, let me ask you a question. What is this? Is it Ruby or is it Crystal? There's a one character difference in this that will tell all. What is it? The question mark, exactly. And let me tell you why is that important. Remember we talked about that this has type checking. In Ruby, everything is everything. It doesn't matter. 1 minute is a string, 1 minute is an integer. Ruby doesn't care. If it walks like a dog, remember we all know that saying. But Crystal is not that way. Crystal will compile and will run to every single line of code or program that you give to it, and then it will try to decide what it is. And it doesn't have to be that a variable is always going to be a string. It might be that an instance variable, for example, sometimes it's a string, and sometimes it is an integer. But you need to tell it that it's going to be like that. So let's take a look at how this code would run or will not run in both environments. So let's take a look in Ruby. Right? So as you can tell, it doesn't have the question mark. Right? So let's take a look at several things. We're going to run this, and we're going to give it a little time. Again, it's Ruby. It's going to take some time. I guess we could do it on 10 instead of 40. All right, but it's taking it on some sweet time, but it's going to get there, believe me. There we go. How much time did it take? 16 seconds. Now let's run that same thing. Let's make it smaller. Let's run it in Crystal. And the thing that you need to understand the way this is going to run, and you can see the command that is going to run on top, is going to say, it says Crystal run. Even though this is a compiled language, you can tell it to compile on runtime, right? You can tell it to compile every single time, or you compile it and run the compile program. Just for sameness, we're going to say, let's just compile it and run it. That's it. What was the difference, right? You got to take it with a grain of salt, right? Everything, every benchmark that tells you is comparing Fibonacci something fishy right there, right? This is not very useful. You're not going to make a living writing this kind of code, right? But let's go through a bunch of things that are similar and are different. Both Ruby and Crystal has to instantiate the whole language to understand what was going on. They have to run through the code and figure out what is going on and then actually run that code. In that, they're both the same. The difference is that Crystal compiles into native code, basically uses LLVM, a toolkit for building language that is very fast. Just to give you an example, other languages that use LLVM is Swift. If you're familiar with it, there's a lot of languages that use that. And gives you something that not only runs in this really nice Mac, but it will run on a Linux machine, Windows somewhat, but let's just say for the moment, on any Unix-like operating system is going to run. You might need to compile it for the different environments, but it's going to run. The same code is going to run really fast. So what else is different? Obviously, it runs really fast. And one thing you might notice is I didn't cheat. One thing I could have done is if I would have done Fibonacci 40 instead of taking it from the environment or defaulting to a value right there, what would have changed is the LLVM compiler could have cheated and basically just say return 40 every single time. Compilers are smart that way. That if they know this function only gets this only input, instead of running through the code, they're going to figure it out and bake it into the compile option. So there are a lot of things that could happen in your code without you having to know about it, that the compiler will be smart and do it for you and will make it even faster. Ruby doesn't have that. And it's always going to create an AST. Yes, it's somehow a form of compilation, but it's going to run through the code every single time. It's not going to change that AST. For talking JRuby, that might be a little bit different. So let's go back to type checking. I forgot to talk about that. The difference in what's a question mark, and what that does is telling the compiler this value could be nil. Because if you realize this, when I ran this code, I didn't pass any environment variable, any arguments to that Unix process I was running. So I had to, if I don't have a number, I have to have a default. So what this code is doing is saying, it's okay, if this argument could be nil. Maybe there's nothing that got passed to this process. So if that happens, then go through the other side of the OR and take 40 and convert it to an integer. With Ruby, it doesn't matter, right? It's going to take both cases. You don't have to be. So another take home from this is with Crystal, you need to think a little bit more about your variables, what values you want to hold in there. And you have to plan it a little bit more. Because let's say I try to run this without it, and let's see what happens. There you go. That's another thing that to me, once I start using this, is a plus. If it's going to fail, it's going to fail fast. It's not even going to try to run. It's going to go through it and it's going to tell you, hey, index out of bounds because that thing is not there or could not be there. So you need to be planning on things that could be there or could not be there. So let's bring it back to what it is. So let's move to the next one, to the next example and go through that. Now, we already talked about static type checking and we just talked about what things could be there and what things could not be there. This is a perfect example. So what's wrong with this? What's the problem with this piece of code? It's a function call just saying, whatever you pass me as a parameter, add +1 to this. If you pass nil, right, in Ruby, you can do a little bit of quacking, right, and move things around and say, I'm going to transform it for you, and then I'm going to let you go. I'm going to let you pass. But in Crystal, that's not going to happen. That's not going to work. So basically, let's look again at this line on that A equals ran. Basically, ran is going to return a 1 or a 0, right? So basically what I'm saying, when it's a 0, A is going to be a 1. When it's a 1, it's going to be a nil, right? So let's take a look at that code and actually what's the error that we get and what's the error we don't get. So if we run that in Ruby, so sometimes it's going to be just fine, right? Remember, this is a random effect. Have you ever had, if you've been doing Ruby on Rails, I'm sure you're going to have a lot of errors that say something like, Neil doesn't know how to do plus. Neil doesn't know how to X, Y, or Z. It happens to me. It doesn't matter how many years you've been doing this. If you have honey badgers, you're going to get emails and emails and emails and emails telling you that. With Crystal, it cannot happen because it runs through the algebra of all the possibilities of what that variable could be. And if that class, Neil being a class, doesn't know how to respond to that plus method, it's not going to let you compile it. It's never going to run. So forget about test unit. You still need test. But it's not even going to compile, so you're not even going to be able to run tests on it. So in this case, let's try to, there we go. Remember, this is still Ruby. Ruby did compile it, run it, and when it randomly got the wrong number, said, sorry, undefined method plus for nil class. Now, if we try to do this in Crystal, same exact code. There's no single character difference, right? So let's try to run it that, and there we go. It's telling you, I mean, the error messages still need some work, and you have to think through what's going on. But if you can see, it says undefined method plus for nil, because it knows that that a variable that we're going to pass to foo as a parameter could be a nil or could be an integer. One cool thing that also, I'll show you maybe later if we have time. But anyway, let's move on to another piece of this. So I don't know if I'm going to have a lot of time to show you a lot of this, but one cool thing about Crystal is there's a difference in being a language that has 10 years of history and 1 or 2 maybe, right? The difference with Ruby when it started is it started with the very basics and had a very basic standard library, and a bunch of gems have been coming on, right? When we talk about a standard library, we're talking about code that comes with the language. It's tested and it's built, and every single release is tested against everything else. What happens with a lot of gems that we use out there is the developer, and I've done this, so I'm not, bashing on anybody. That you get excited about something, you build a gem, and later on you abandon it, right? The language keeps changing, but maybe that gem is not as useful as it was before. The good thing about a lot of these things that you're seeing here, for example, RSpec, CSV, JSON, XML, YAML, HTTP clients and servers, OAuth, secure random, HTML builders, they're all built into the language. They're going to keep being there. And every time the language changes, gets updated, all that gets updated too for free. So those are things that you can always build, and they're going to be there. There's nothing else you need to download to use these kind of things. So that's why I think that's cool about the language. It's a newer language that knows it has to have these things built in. Now, let's talk about speed. Tell me if you've ever run a Rails app or even a Sinatra app that you can measure the request in nanoseconds. Can anybody raise their hands on that one? I haven't. I've tried. I've done my best. I even tried JRuby, and it never gets to nanoseconds, right? So let's try this. Let's see it in action, because I think it's one of the reasons that I love Crystal. We're going to create a very simple, but with some nice things built into it, web server. So let's run a little bit through the code and what's going on. We're just loading some, again, standard libraries in there, the HTTP server and handler. And basically, all you do is build handlers. And it's more inspired, I think, into what, a little bit from Bragg, but also from Node and Express and all that. So we're just we create an array of handlers. We're deciding what the host, the port is going to be. But we're going to have an error handler. So if something goes wrong, we present something nice. We're going to have a log handler so we can display what's going on and how long it's taking. And we're also going to take a static file handler so we can display just basic static files. Now, when we create that server, we just say, here's a host, the port, what are those handlers that we want to include? And here is a main block, just like in Ruby, that we're going to tell it what to do when none of the other handlers can respond to that request. So basically, we're saying that the content type is going to be text plain, and we're just going to say hello world. So let's run this. So that server is running. Let's have a little window. And let's say localhost 8080. There you go, 660 nanoseconds for you. And what it did, the static handler took over because it didn't recognize that as basically your default index HTML, and then you can take a look at those files. Now if you click on that, now it's serving a static file. And that static file, again, took almost a second. Let's refresh that page, and now you can see it took 31 nanoseconds. That blows my mind. I don't know about you, but that, say what? Well, yeah. It's way less than what it would happen any other way, right? So, and if you want to put a route that it wasn't defined, like X, then it's going to run through that block that we gave it. 26, 37, and there you go. So the other thing that you need to see with this is how much memory this is using. So let's take a look and see if we can see that. Yeah, you're right. My icons are not there. So take a look at that. CPU, obviously, we're not doing anything concurrently, but look at the memory. This crystal thing, it's what's running inside of 8, but that 1.2 megabytes is that web server. Can you run any Ruby app that's going to take 1.2 megabytes? I haven't been able to. Or Java, for that matter. So I guess my point with this is a lot closer to what would you expect if you're running a Swift little web server, a Go little web server. The speed is right there. And actually, people that have done some serious benchmarkings have compared it can actually be faster than C in many other cases. Sometimes if it's not faster, it's very close to it, but it's comparable to it. And I don't know about you. I don't know much C. I know very little. But if I have to create a simple little Sinatra app, I will definitely not reach for C. If I have something that uses the same memory and has the same speed.
MySQL and Redis become like a huge bottleneck. Because like basically like if you're just trying to add pages, I mean you're literally talking 23 microseconds versus 40 milliseconds in Ruby. But then still if you're like running to a database or reading from a database and you're in like 2 or 3 millisecond calls. So
every time we start talking about Ruby slow, Rails is slow, let's talk about the elephant in the room, right? Your language is only this piece of this stack. As soon as you're building any app that is using more than one server, for example, right? I mean, you're going to have a load balancer. We have 3 front-end servers, 2 database servers, a master and a slave, a utility server sitting right there. We're talking full-on hardware. This is not virtual environment. This is actual real servers, 32 gigs of RAM. We have an Nginx in front of it that distributes to our little Rails apps and all that kind of apps. Again, we have Postgres, we have Redis, and other companies have used other things, our Memcached. And if you start looking and really benchmark what's going on with every single request, you're going to see that Ruby on Rails is this much out of this thing. has to go through a lot of connectivity, especially if you have multiple servers. This, and you have your database server over there, and you have your Rails app over here, or C, or whatever it is. There's network connectivity that needs to happen every single time. And how many requests are you going to do? Even if you have a connection that is staying connected all the time, all that is taking time. It doesn't matter what it is. And you're right. All that is going to balloon up, and Rails does a good job of showing you how much time it runs doing views, doing queries, doing all that. And all you need to do is look at the numbers. Honestly, there are things that speed and RAM usage is still important. I mean, if you have 32 gigabytes just for a front-end server, there's a lot of things you can do. When you're starting up and you're paying $5 for DigitalOcean, believe me, having a difference between a 300 megabyte Rails app and a 1.2 Crystal app, does make a difference. You can put a lot more things into that one server. But, so anyway, I want to talk a little bit about concurrency if I have time, but I think I'm missing a whole lot of time already. So let me try to see if I can finish up and see how much time we get. So one thing you lose with once you start doing type checking and compilation is this whole thing about Ruby that gives you all this freedom that you can generate classes on runtime and make up your world as you go. It's kind of like Minecraft, right? You start building it up, once it's running, you can change everything and everything's cool, right? Crystal's not going to let you do it. Everything has to be built and created at runtime. That's the only way it can do type checking and tell you, no, that's wrong. You cannot have a nil right there. So what kind of things can you do that are meta-programming like? You can define basically macros that if you come from other languages, those will look very similar. And let's look real quick at an example of that. This is kind of cheating because the Crystal, the language, has this thing already defined. They actually use macros for it. And one of the cool things, about Crystal is it's about 98, 99% built in Crystal. So it's kind of like Rubinius. If you ever looked at Rubinius code, you can see how array is defined and how array sample and sorting and all that and numeral in Ruby code. So it's kind of really Inception-like in how it's, turtles and turtles and turtles and turtles, right? Everything is readable and understandable. I'm not going to show you that code, but what I'm going to show you is one way you could define these basic things that we have in Ruby: attr setter, attr getter, and attr accessor, right? And this is how you define. You can create macros that all they need to do is output valid Crystal code. So how do you define a setter? You just gave it a name, and just like in Mustache, you can define your little template that is going to turn out into Crystal code that the compiler then is going to compile. So you define a setter that way, you define a getter that way, and then the accessor can call the macros you already defined before. So you can build macros on top of macros on top of macros and build your own DSL, your own little language for yourself. It has a lot of limits. Again, it's at compile time. So there are very few things you can actually create at runtime or basically at compile time. Right? You can recompile your code. So it's very limited, but this can let you do things like if you look at Kemal, which is basically the Sinatra counterpart in Crystal, the same fancy things that you can just say get, dot name, something, do, and define your routes that way, you can do it in Crystal too. And they're all doing it using macros like this. So again, it's very limited, but gives you some flexibility.
Is it possible to have that run like a system call on idle time?
There are a few ones. There are a few little things, but I haven't played with them myself. Yeah, honestly, yes, you can read templates and stuff like that. ECR, basically the ERB counterpart, that kind of does that. Yes, it's similar, but again, it's very limited. And when you start going that route, you're kind of getting lost in the forest, I think. That's my personal opinion, right? But it's not the thing that they're shooting for. And right now, it's a kind of being born language, kind of being reborn again, actually. So it's kind of hard to stay on the fringes and expect it to work, 3 months from now, right?
I was trying to auto-populate my column names in my database, like Active Record does, and I could do that with macros, but it turned out to be way harder.
No, I think for what Active Record does, you need to do it at runtime, and you just need to be really smart and play with that. There are a few libraries out there that are trying to do that. Chemalist has one built in right now that I think is the one that is still staying on top of things. But it's a real hard problem. I mean, Active Record does a lot of things for us that we just take for granted. So the only one thing I wanted to show you on this one, there's not a whole lot of value to this, but the one thing that you can see here is that we did define a reader and a setter, and a reader and a writer for name. We only define a getter for age, and we only define a setter for gender. And basically the example is we wrote Marcelo with 25 years, but then we found out we were wrong. It was Marcela, was a female, but we couldn't change the age because we didn't set up something there. Another thing that Crystal does is it doesn't let you cheat like Ruby does. Ruby, you can define what are your public methods, what are your private methods, but you can just send and screw that. I'm still going to call it even if it's private. Crystal's not going to let you do that. So what else do we have? Like I said, again, it's basically 98%. This is an old screenshot, but pretty much the whole language is built in Crystal. And the whole standard library, even basic things of the language, you can read to it and figure out how it was done. And I've done quite a bit of that, and it's very easy to read. The only thing that is hard sometimes is because it's very close to the LLVM, there are things that they are very smart about how you move things to be fast. Sometimes it's not just the language that is fast, it's the way that you deal with the basic underlying structures, like if you're copying a file, instead of reading everything into RAM and dumping it over there, take little chunks of it and move it one by one. That's not only faster, but doesn't use it as much RAM. They do a lot of optimizations when dealing with some of the lower pieces of the language. Some places you can go, there's a lot of things going on. I think one big thing that is happening right now is, if you're familiar with Scikit coming from Ruby on Rails, the guy that built Scikit is really psyched about Crystal. It's the only language that he has even tried to replicate this and work. And he's talking about having 10,000s of job a minute running in Crystal as opposed to like 2,000 in Ruby or something like that. I don't remember the number, so don't quote me on that. Yeah, it was incredible. In those cases, that's where speed and RAM really is important to you. Let's say you have something that is really, I don't know, let's say you're a mail guy, right? And suddenly you need to send a mailing list to 10,000 people. And you need to have all these off-queue jobs, right? Off-request jobs that need to go out. And if you're spending 300 megabytes of RAM per process, like any Rails app will do, at least, right? And whatever it is, 500, 300, whatever it is for your app, right? And you have, even if you have a 32 gigabyte RAM server, how many of those can you spin up? Because those are going to go up, they go down. How many can you spin up? How many emails can you set out at the same time? If you only have to spend 1.2 or even 5 megabytes of RAM, and that's going to do it 2 times, 5 times, 10 times faster, how much money can you save? Now we're talking real money, right? So anyway, that's pretty much it. I don't even know how much time, but I think I already took too much. But I guess my parting thought is learning other languages is always a good thing to do. It doesn't matter what language it is. When you try to play with something, even if you fail, I took one of those online courses on Scala, and I hated it. I hated the course. I didn't hate the language, but I hated the course. I failed completely, miserable. But I came out of that just thinking more functionally on everything. In Ruby, a lot of times it's just so easy to read and whatever, and we just throw things out there and abandon them. but it helped me to use more blocks and enumerable a whole lot more than I was using it before. And with Crystal, it's a lot easier to come from Ruby because it's so similar. But at the same time, having to think about what types this variable should be, right? Not what they could be, what they should be. And planning ahead has helped me a lot to realize, even on my Ruby on Rails code, how can I build things differently and better. And also just having some of these things that can go so fast and so quick with so little effort and so little CPU and RAM usage makes me think, okay, what is the next thing that I can speed up, just make it a different, a separate service and run it just in this. Because the speed, the RAM usage is going to help. So anyway, that's all I have. I hope I have piqued your interest rate and that you want to check it out and play with it. I think you're going to enjoy it. So,
play.crystallang.com is probably
yes.
for people that don't want to do
So one thing that is cool was Crystal Lang.
Yeah, no, there's like
There we go. One cool thing about this is it lets you create code and run it directly. They will compile it directly on their server and run it for you. So you can say, and you can even choose what's the version. It's not super fast, so but the cool thing is if you don't know the language, you can run this thing directly on your local computer, so you don't have to wait on speed or whatever. But anyway, there's a lot of things, and if you got questions or if you're thinking of something that would be nice to do in this, just chat afterwards, and maybe we can figure something out. So anyway, thank you so much, guys. Okay.
Kind of like being able to sit down. This is kind of fun. So I've been working on a little project for, well, I tried it a couple months ago and it failed miserably. But I tried it again a few weeks ago and kind of got somewhere. And it seemed kind of promising. And somehow Ben coaxed me into talking about it. So don't know how that happened. Okay. So this is writing native extensions using Crystal. Now, does most everyone know what native extensions are in Ruby? I'm not sure if they talk about that in DevPoint or whatnot. Basically, it allows you to write C code, compile it, and call it from Ruby. It's much faster, obviously, and a lot of very important libraries. Nokogiri has a C extension. OJ, the JSON serializer, has a C extension. There's tons of C extensions for hugely vital things. But the problem is, I don't know C, so I can't write a C extension. Outside of being able to read it, because I took a class on it once. And Adrian mentioned he doesn't know C, so that's great. Adrian's very senior and he can't write a C extension. And a lot of people just can't. But there are definitely times when we do need to make something in Ruby a little bit faster. And so that's kind of why I had kind of wanted to explore, can we write C extensions with Crystal? And so, okay. You know, there's the why. Why would you write a C extension using Crystal? Well, typically, we want much better performance. That's why we're looking at a native extension, because we need some better performance. But why Crystal specifically? Well, it's a lot easier to develop than C. It's a lot easier to learn than C. And especially coming for us Ruby people, just like Adrian showed, it's very similar. You can probably get something up and running really quickly with it. And what it all really boils down to is feasibility. I've worked at a couple places that, for the most part, you're happy with the performance of your app, but there's little parts of it that are really slow. And unfortunately, those tend to be more important pieces of your app too. And that gets a lot of CTOs and directors talking of, hey, maybe we should pull this out and write it in Go separately, and people cringe at that. Or maybe we should separate it somehow, or do something kind of drastic that doesn't sound very fun. Luckily, I've avoided having to do anything like that. But if you can pull something out and translate your existing code to Crystal, get it working, and then connect it directly to whatever app you're running, that's something that I can do, Adrian can do, really anybody can do. It's quick. You can test it very well. There's a high probability of success, and you have the resources to do it. A lot of times these big things, you don't have time to do it, or the devs that are capable of doing it. But something like this, you probably do. So I thought to myself, let's experiment. Let's try to do something. Take something in Ruby right now that might not be the most performant, and take it over to Crystal. So active support is a good example. Active support is entirely Ruby. There's no C extensions. There's no Java extensions. It's all pure Ruby. One developer, Sam Saffron, created a gem called FastBlank, which was a C extension that literally all it did was, it's the method blank for a string. And when he did it, it was 20 times faster than the active support method that did the same thing. So it's been done before, the concept. It's obviously worked, so I thought, let's try it with Crystal. So I looked through quite a bit of active support stuff and kind of went looking for something that I could wrap my head around and port well enough. And I found active support inflector, which does things like it pluralizes words, or it turns things into singular, it does camel case, it does underscore. A lot of those extra additional string methods that you get with active support are coming from the inflector module that it has. And since it's all string operations, that seems pretty straightforward, and I thought, okay, I could probably tackle this, and I might not cry too much during the process. So I'm like, okay, that sounds good, let's go. So basically, I took active support inflector, which has like 4 files. I'm not going to show them all, but it's kind of decent, but it's not too bad. And I ported it over to Crystal, and I just wanted to, it was just an experiment. I just wanted to see what would happen. So I don't know if anybody knows the squint test from Sandy Metz, but this is a even worse version of it. But basically, on the left is 1 file out of active support inflector, and on the right is the file that I ended up with. Everything in blue from the active support version, I literally copied that over. I didn't touch any of that. And it went directly over to the Crystal version. There's a tiny little bit in red, about 4 lines. Those I actually had to work with. I don't think that's that bad. And anything else, which is only a few more lines of white, is stuff that I had to look at it, and I had to tweak it, but it maybe took like 10 seconds. On the Crystal side, to fix those 4 red lines, just a tiny little bit of green. It's really not too bad. And if you look at it and you realize, oh, 80% of it, I just mostly copied and pasted and didn't really have to touch it, that's pretty exciting. That shows, it goes back to the slide that Adrian had where he had a Crystal, Fibonacci and Crystal, and the only difference between that and the Ruby is the 1 question mark, the 1 character. There's a lot of situations where you can copy code over, and even if you had to make changes to it, it's very minimal, and you have something that's working. There are a few slight differences with Crystal, with strings specifically. So in Crystal, strings are immutable, which means that you can't change it in place. And there's a few things that this really means is, first of all the bang methods that we have for strings don't work, because those modify the actual string in memory. So I had to replace those. It's not a big deal. We'll take an exclamation point out, and we'll just reassign the variable back to the same one that we had. And also, since they're immutable, there's no freeze method, because in Ruby, the freeze method makes your string frozen, so you can't touch it. Well, we don't need to do that, so we can just take that out too. In Crystal, all strings have to have double quotes. You can't do single quotes. Active support put everything in single quotes, so I had to do one little find and replace and tweak that. But again, not a big deal. And then the last thing is with regular expressions. This is a little more complex, but with a back reference, you need 2 backslashes instead of 1. Okay, that was pretty simple. So those are really the biggest changes, that I had to actually go through and make. There are a couple other things where there's some logic, but even the stuff that I couldn't just copy and paste directly over is still not that bad to change. So now, that was kind of fun. I'm thinking, well, is that it? Kind of. Yes and no. There's a few steps remaining if I actually want to hook it back up to Ruby. First of all, to go between Ruby and Crystal, I actually had to convert, the variables that we pass back and forth between Ruby types and Crystal types. I had to wrap the Crystal method, so you'll notice I didn't have any code that kind of said, hey, take Ruby, put it in here, and bring it back up. I intentionally want that separate so that I can have a Crystal library that works as a Crystal library in a Crystal project. And if I want to pull it into a Ruby project, I can do that. One more major thing is I have to initialize those Crystal methods that I'm going to write and basically allow them to be accessed by Ruby. So I have to tell, there's a C API for Ruby native extensions that I have to tell, and I have to say, hey, this method exists, and I want it to be accessible by Ruby, and this is what it's going to be. That's pretty straightforward, but it's just one more step. And then after that, I guess I have to write some Ruby and actually take advantage of this stuff. So the data conversion, with the C API that Ruby has, everything is stored as something called a value type, which is defined. This goes back to what Adrian was talking about how in Ruby, you can change object types as much as you want. You can do duck typing, and nothing really cares. As long as you don't break something, it all works. And it's a little trickier when you're going into C-land, but that's how Ruby accomplishes it. Everything is just this value object, which is great. And that just means that you just have to convert that value object into a Crystal object, which, if you know how to do that, isn't too bad. And luckily, this has been done before. And any good developer is going to leverage other good developers' work instead of redoing it themselves. So that's what I did. And we have, this is just an excerpt from basically a library that handles it. On the left, just that little bit in green, just opens up some C, just enables some C functions that are in the Ruby API. If you want to read it, you can try. It's not really meant for that, but it just shows you there's not too much to do. There's lots of documentation on it. And again, there's people who have done this before, and you can leverage what they've done. And then on the right, there's just a little bit of code that translates between a Ruby object and a Crystal object. And you can see there's not too much there. This handles strings and integers, and it's just a few lines. And again, this is not stuff I had to entirely figure out on my own, because that, if that was the case, I probably wouldn't have even been trying. So now, all those Crystal methods that I wrote, all the active support stuff I ported over, I had to have some way for that to get connected and go in and out from Ruby types. So I don't really have to do it that way, but if I want to have a Crystal library that I can reuse in a Crystal project or a Ruby project, or if I want to take something that a Crystal programmer put together who doesn't do Ruby, but it would be useful, I can pull that in. And it's just a cleaner way of doing it. Again, if we want to use an existing library, it also allows for a little bit less code on the Crystal side. We're not repeating code as much, and it enables a little bit easier debugging. And it's really not too bad either. So again, here are just some wrapper crystal methods, and if you can't read them, that's okay. They all pretty much do the exact same thing. The first step is they convert from a Ruby type to a crystal type. They just create a string. The second is they just call a method on the string. And the third step is they convert it back to Ruby. They all look pretty much the same. It's pretty simple, but it allows all of our code to be nice and clean. There's one more step. Like I talked about, we had to initialize C functions so that Ruby can actually access these. And this is another thing where other people have done a lot of work before I came along, and I leverage their work because they're smart, they know what they're doing, and I don't. And so let's get back to some Ruby usage. And as you can see, it's pretty simple. We just require a crystal file that we have. We compiled it. And then we just call methods. I prefixed all my crystal methods with CR_, so that I could benchmark them against all the active support methods that exist. So we just call them just like any other method. It's pretty straightforward. And they can this can be really beneficial. So I finally got done, went to bed, decided to take 8 days off from this because it made me cry a little bit. But then I came back and benchmarked some of this against actual active support. And I used the benchmark IPS gem, which is incredibly useful, and it basically counts iterations per second. So how many times can you do something? And there's the active support column, which has a whole bunch of big numbers. There's the crystal column, which has some bigger numbers. But the far right column is what I think is the most interesting, which is basically how much faster are the crystal methods, which again were 80% copied over. The code was copied over directly. How much faster are those methods than the active support methods that Rails uses, that we use every day, and under the hood especially are used thousands of times, per request. And they're all faster. Most of them either 3 or 4 times faster. A couple of them almost 5 times faster. And again, this was basically a weekend project, more or less. It took me a couple hours to copy all the active support stuff over because it was pretty simple. And I just worked with a little bit of knowledge that other people have put out there online for me to take advantage of. And suddenly I have something running a lot faster than what we're using every day, with very little work, to be honest. And really, it's not as much about the specific active support speed up, but it's getting back to the general concept of you work in a big app and you might have one bottleneck that is pretty important, but you don't have the time or resources to work on. And now suddenly, if you try using Crystal and hook it back up to Ruby, suddenly you can take a week and you might be able to fix a huge issue in your app in terms of performance. You might be able to take the most traffic page, or say you've got a background job that does lots of data computation, or say you're doing emailing or some processing. Suddenly you can take that, and with just a little bit of work, you can make it a lot faster. I know one problem that I've talked to some people about. They run 20,000 Sidekick jobs every hour. They start them all at the same time, and they more or less pray that they finish within an hour because there's about to be 20,000 more jobs. And unfortunately, as their app grows, they're going to keep adding jobs and adding jobs. And at some point, it's just not going to work. They're not going to be able to go through all those jobs in an hour, and they're going to have to completely scrap it and do something else. Well, it's just data processing, and if they can offload a little bit of it to Crystal by taking what they currently have, changing file name and tweaking it a little bit, take a day, they might be able to run 200,000 jobs an hour now. And they don't have to worry about this problem for a year or two. Maybe. If they're successful, it'll come sooner. But it's just an interesting idea. There's a lot of hype around native extensions with Rust right now. That's something that's kind of been in the news online the last couple of weeks. There's a project called Helix that'll make it a lot easier and make you just have to write a few lines and you'll be able to hook up to Ruby. And things like that are really exciting because they can, using them can alleviate a lot of people's concerns about using Ruby, about can we scale with Ruby. And it's exciting to be able to try to bring people back who are trying to leave the Ruby ecosystem. And something like Crystal, well, I've looked at Rust, it's really cool, but my head starts spinning when I try to go through some introduction docs and try to learn it. And Crystal's a lot easier and you can still get great performance with it. Yep.
I was wondering, if you were to try to turn this into a gem, would you just compile that crystal and include like the cross-compiled binary along with the gem, or would you have it compile automatically on their system and download it and install it, or?
So I'll repeat it. So his question was if you wanted to distribute something with Crystal as a Ruby gem, how would you do that? Would you have to cross-compile and then upload the actual executable files, the binaries? Or would you be able to include the source code and have it compiled when you install the gem, which is how most C extensions currently work? Worst case scenario, you could cross-compile and upload that to Ruby gems. Ruby gems does accept binaries. I think you'd be able to have it so that it actually compiles on install. And basically, Crystal would just be another system dependency, kind of like when you install other things in libxml or Nova, for instance.
Or even like MySQL 2.
Yeah, exactly. MySQL 2 gem won't install if you don't have MySQL on your system.
And like all the Xcode developer tools and everything.
Yeah, exactly. So I'm pretty sure I'm going to get there eventually. So we'll keep in touch. But I'm pretty sure that you'd be able to distribute it like that and have it compiled at install time.
Okay.
And again, worst case scenario, cross-compiling. Yeah?
This is more like one-off little things. So if I'm running into issues with the venues and Crystal Pass, or having two different libraries that I go because now Crystal has two of them to combine two Crystal libraries that you run at the time. Does that make sense?
I think so. Are you asking about like concurrency?
It has a venue, right? And that's how we have the concurrency anyway.
Mm-hmm.
So if it's just a job that is a string transformation, right, that's not important. Like there's something more involved that's not only responding to fiber, and different things like that. Some people have running an eventually that you pay attention to. Kind of like a better machine does and Ruby stuff.
Right.
So have you tried any of that? Try to use some of that currency from Ruby?
Not yet. I've mostly tried. I started with a proof of concept, and then when it actually worked, I kind of wanted to try something a little more than a proof of concept. In terms of concurrency, I honestly don't know. There is some discussion online about whether or not Crystal would be a good idea for native extensions, mostly around the fact that it has a garbage collector. Thank you. I cannot think of the word. And there's some other concerns. I don't know enough to really be able to say whether or not that's always the case or just sometimes, and I haven't dealt with concurrency. I think that for smaller things, string operations like this, I think that Crystal would be good. I have done some benchmarking in terms of memory and some other stuff just to see, if you have, long-running processes, which is a Rails app, more or less, a web server, do you end up with, either memory leak or timing issues, if you hit a GC cycle. Yeah, exactly. And so the benchmarking I've done doesn't show any problems, at least with this sort of thing. But I think when you start to get a lot more advanced, you might. I just don't know.
I wonder what happens with non-running also, right? You create some object that will full time for days. Is it still going to be able to think or?
Yeah.
I don't think that's a problem if you're just always returning a Ruby object, right? You're processing and returning something Ruby, you know how that is. But if it's a crystal, long running object, what happens?
Right.
I just wanted to know that answer, yeah.
Exactly. So just make sure you're doing daily deploys, and then you'll be okay.
I ran a camel server for like a month and a half, and it still had very low memory.
I'm wondering the combination. You can
Yeah,
combine-
yeah. When you're embedding it, that's
Crystal process. Yeah, I love it, and I wonder one of the things that we can build over the next few years, right? Some of the things that they don't have yet, like the next generation of the world, which are super strong. They do that, right? You have to make it crystal. Use the data, give it PDF, and work on it.
So if anyone's hopefully still interested in Crystal, I know Ruby's exciting, but Crystal's fun too. As a little brother, there's some resources there's a lot of resources actually about writing C APIs or C extensions and the C APIs that go with it for Ruby, and really all that documentation still applies for working with Crystal. There's a lot of great resources for Crystal too. I was at Ruby on Rails a couple months ago, and Will Weinweber gave an excellent talk about Crystal, really for Rubyists. There's more resources online that are specifically targeted at Ruby people, and introducing them to Crystal and kind of getting them interested in it. I think it's an exciting tool. It's early, but I think it has a bright future. And I don't see it as a replacement. I don't see it as a, hey, let's all leave Ruby for Crystal. I see it as when we could have an improvement by dropping a little bit of Crystal in, we can probably do it quickly, easily, and, still continue with whatever we're working on. Any other questions?
Do you have a repo for this?
I do.
It's really easy to find on Google.
So I have 2 repos. I actually broke out the inflectors into its own repo. Crystal actually has a package manager called Shards, just like Ruby Gems, except it's decentralized. So there's actually a Crystal shard for inflector, which is the entirety of active support inflectors in a Crystal shard. So it can get dropped into a Crystal project. Nobody has to care about Ruby. They just use it for whatever they want. And then I'm actually pulling that into this project and wrapping it and connecting it to Ruby. So I have 2 repos. I might have more in the future because I'm actually kind of having fun with this. And then Crystal Lang, there's also obviously a repo. And then if anybody wants slides, I can send them. I don't know if Ben, if you want to stick a copy somewhere, I'm more than happy to do that.
Well, thank you all. That's actually really exciting. If any of you are interested in that, talk to Paul, talk to Adrian, because they're looking for people who are probably also interested.